as a spatial analysis and mapping tool. This is a free software that I use regularly when I am thinking about snow science topics, but also when I'm recreating in spaces where I need access to topographic maps. You can use this in a free format or a paid format, depending on what sort of features you want. To use the free format, just go to caltopo.com. So just type in caltopo.com. You'll navigate to a page that looks like this or something like this. You can click Start Mapping. That will pull up just a generic map of the US. So how do you navigate in a space like this? There's several features that are useful to you. If you already have an account, you can just go ahead and log in. You can, even with a free account, you can create an account or link it to an email, and that will allow you to save a certain number of maps to the public. If you have a pro account, which costs you 20 or 30 bucks a year, you get access to high-res satellite imagery, which can be really useful for snow science because you can map out where the snow is at any given moment in time as a function of terrain. But you can also save and store as many maps as you'd like. Okay, so once you get to this pane, what are you looking at here? So you have a variety of layers that are presented to you over here on the right in this map layers section, and then you have any map objects that you've created. Those include points and lines and polygons. We don't have anything because we haven't created anything yet. So if I want to go in to, say, zoom into a particular area, I can just scroll or double click, and that's going to zoom in on a particular area. Or I can copy and paste coordinates from a location, say from Google Maps or from another source, or I can type in a common name. I can type in, say, Wolf Creek Pass to get me right where I want to be. I can look at Wolf Creek Pass. If I left click and hold, I can pan around. If I scroll back, I can zoom out. You can see for Wolf Creek Pass, this is Highway 160 coming up the pass. Here is the actual ski resort. You can see the lifts are these dashed lines. They're actually named on this map. Some other useful tricks here. Any place you put your point, at the top right of the screen, you can see the numbers are changing. So that's a real-time elevation and latitude, longitude reading, which can be handy. Under base layers over here, I could choose the type of map that I want as my main layer. I like to use Map Builder Hybrid often, or Map Builder Topo, depending on what I'm doing. Sometimes I'm trying to extract information that the Forest Service may have charted that is not on one of these generic topos, and so I can choose a Forest Service map, and then I can choose which year for that region. Different regions may or may not have recent Forest Service maps. Most of the contiguous 48 have them, but if you're in Alaska or of course Canada, then you may not have them. So I like the hybrid. The hybrid uses an overlay of the topographic map and satellite imagery, so you can see the orange contour lines that mark elevation, and you can also see sort of a transparent layer behind that, which shows you what the vegetation layer looks like. So you can see where trees are, where trees aren't, which can be handy. The Map Builder Topo does the same thing, except it's not overlaying the actual satellite imagery. It's just projecting that onto this opaque layer, which is green. Whatever's useful to you, it's nice to play around with. There's a variety of other things. If you have Pro Service, this is when you get access to all of these high-resolution satellite imagery, which are useful for applications in snow science as well. Okay, so I'm going to look around here. What are the things that I want to be able to do here? Well, there's all sorts of stuff. If you want to look at slope angle, you can go ahead and create a map overlay here. So I can choose slope angle shading. I can choose the scale, whether I want a gradient scale or a fixed scale. You can see the scale is then located down below. That's the legend. So that tells me where things are steep. or flat. This is really useful for trip planning and for project planning to make sure that we don't enter into any unsafe avalanche terrain while we're digging our snow pits. So anything that's colored, of course, is in excess of 27 degrees here. I can zoom around. You can see that I can also select a variety of other overlays here. Things that I find to be really useful, especially in this class, and things that you'll need to be able to do are slope angle shading for sure, and the sun exposure. So sun exposure gives you a variety of things that you can choose from in terms of plotting the overall sun exposure on any given slope or topographic regime. I can choose certain days of the year, or I can select today, which is the default, and then I can choose any time of day, or I can average the total sun exposure over the day. I often like to use the average tool when I'm thinking about snow science, because I don't really care as much about specific times of day. Although if I'm planning a trip into a zone, then certainly knowing when sun will hit is really useful. But if I'm thinking about snow metamorphism, mostly what I want to know is how is the sun interacting with a particular slope at any given moment over the duration of the day, and in which case the average becomes really useful. So other layers that are fun to play around with, but probably less relevant to this specific class, but I find myself using in my daily life pretty frequently, are maps of where the public lands are. So you can see the scale or the legend down here. So this is all U.S. Forest Service land. If I'm looking for BLM land for whatever reason, I can look for these sort of brown or orangish regions. If I zoom out, you can see that this is a huge national forest area, but you can see how the public lands move across this sort of southwest region of the state. For the geologists, you can use the geology layer. So you click geology here and then click geology info to see the legend. You can see the various geological types and formations that exist by area, if that's relevant. And sometimes relevant to snow science, and certainly avalanche forecasting, is fire history. So if you click the fire history, you can see specific fires and their names and their burn regions, which can be really important when you're thinking about how snow is being influenced by solar radiation and exposure in the absence of vegetation compared with other zones or regions that are in the adjacent areas. Under forecasts here, you can have weather shading. This is not that useful for snow science because there's a lot better ways to extract higher resolution data for particular zones, but this can be useful if you're trying to plan trips in the future or plan how you're moving through a particular zone or location. Similarly, the wind plot is not that useful for snow science because we can get good historical wind observation data from NISA West or SNOWTEL, whereas this is more for future or current planning if you're about to go into the field. And then lastly, under forecast, you can click this avalanche button. I don't find this to be particularly useful, but it might be relevant to you. This zooms you out and just overlays the CAIC avalanche map directly onto your CalTopo layer. You know, these are very large zones that you probably already know about or are able to sort of transcribe by looking at the CAIC report, but if it is relevant, you can overlay that. You know, there's no fine-grained information here. The zone is the zone, and that's why I don't find it to be particularly useful as a layer. Okay, so a couple other things. How do you add features? You just click this add button over here. If I want to add a marker, I click marker. That's going to position the marker in the middle of the screen, and then I can left click on that marker and drag it to where I want. Or I can type in a particular GPS location, which will center in the screen, and then click marker, and that will put that dot exactly at the right coordinate. Or my third option is to paste the coordinate directly into the coordinates box after I've clicked add marker. So as you're creating your snow pits, say you dug a snow pit right here, you could say snow pit 1, 1, 18, 21, and you can change the style or the color. You can create folders here if you're putting lots of stuff on your map. In this case, for simplicity, I'll just click OK. There's my snow pit. It's going to prompt me to log in, but I'm not going to do that. And I can add a variety of other things. I can add a line. So what's nice about these topo layers is these objects are interactive. And so say we park right here and I want to just chart how I'm going to navigate through this area. I can actually snap my line directly to an existing trail and mark that like so, and then maybe I type this as my path to pit 1 and click OK, and now I have my pit. I can look at this path. I can choose profile, for instance. That will chart this height profile. It'll tell me the total length, which is a half a mile. You can see the dot move along the length, so I can see any particular region. I can see that I'm going to go up 365 feet and lose 5 feet of elevation. And I can choose expand, and it gives me all sorts of additional information about the max and min elevation, my average elevation, the aspect that I'm covering over the length of that line, the tree cover, the land cover, and the slope angle. And then you can see the slope angle as a function of where I am in space along this linear path. So there's lots of useful information here, some of it relevant to the class, some of it relevant to just using and planning trips and excursions at other times. Okay, a couple other things here. If I go over to this ruler looking tool, measure, I have lots of different measure options here, some of which I will and won't go into. So I can measure a bearing, I can measure a profile, which I actually just showed you how to do. I can get terrain statistics, which I just showed you how to do along a path. Sun exposure, I already showed you how to do. Simulated view is interesting because it's sort of like Google Earth, where you can simulate a particular view on the ground by aspect or bearing for a specific location. So if you're looking at a topo map and you're wondering what is this going to look like on the ground so that you can recognize a particular point or marker, you can click the simulated view. I'll let you play around with that if you want. What I find to be very useful is I can chart point forecasts in NOAA. So if I click the NOAA forecast, then I can click anywhere on my topo map. I can zoom out, I can zoom in. But say I want to know at the top of this little peak here, I want to know what the weather is going to be in 2 days because that's when I'm going to be there. Then I click this, and that's going to pull up the National Weather Service as part of NOAA. And it's going to tell me for this exact location, latitude and longitude and elevation. So you can see the elevations here at 11.8. And it's going to tell me the summary and the short-term forecast. But what's really useful is I can scroll down to this hourly weather forecast, click that, and this is what I use most frequently because this tabulates my data. These are all forecast data. These aren't observations, so they're being charted from now into 48 hours in the future. But you can see here this first pane, I've got wind chill, dew point, and temperature. The grayed areas are night when the sun is down. The white areas are when the sun has risen, and they're actually correlated with actual sunrise and sunset times. So you can see what the duration of the day is and the temperature associated with that. Second pane shows you the surface wind, which is this sort of purplish layer, and these bars show you the direction that the wind is coming out of, and then the dashes show you what the wind velocity is if the numeric value wasn't there, so it's redundant in this case. And then this bar here shows you if there's any gusts that are going to be present and what their wind velocities are. The third pane shows you the humidity, precipitation potential, and then the percent sky cover in blue. So that's going to tell you whether it's going to be a nice bluebird day, a clear day, or whether or not you'd expect to see some clouds. And then you have rain, thunder, snow, freezing rain, and sleet, all as probabilities with what their accumulation potential is in inches. And so this is really handy. You can choose different dates here or different times. You can go forward 2 days. You can do this up to 7 days in advance. You can see for Wolf Creek, we're expecting Saturday during the day to see some snow. You can see the sky cover goes up because of the snow, and you can see that the air temperature is around 23 or 24 with winds that are out of the southwest around 18 to 17 miles per hour. So this is a useful tool. Okay, last thing I want to point you to is how do you get this data as a map to use, say, in your technical report for the class or as a printed map for navigating from. There's a variety of ways. The simplest, easiest, fastest way, if you don't care about high resolution data, is just to screenshot this. The way that takes only a little bit longer is to click this print icon here. And that pulls you into a new pane, and then it gives you this CalTopo printing option off to the left where you have a bunch of different settings you can play around with. The red overlaid box here shows you what the print area will be when it prints. This is a page size of 8.5 by 11 inches. If I left click and hold at the center, I can drag this object to center it on the area I want to print. So maybe I want to print just this region here that I'm in. I can drag by the corners, and it's going to keep the same aspect ratio because it's fixed at this 8.5 by 11, although I can change this to a variety of different things. Just kidding, you can't unless you have the Pro version. Scale, we have not fixed. That means that it's going to allow me to adjust this. And DPI is dots per inch. That's the resolution of the printed map or the digital map. And so typically 200 is fine, but I use the Pro and I use 400 if I'm going to navigate from this map. I want as much detail as possible in the digital form. The format here, I can order a paper map, I can produce a JPEG image, or I can produce a geospatial PDF. What that means is you can read that with any PDF reader, and what happens is the PDF reader assigns actual GPS coordinates for every pixel within the map, which means that you can have a PDF map offline when you don't have access to cellular data or Wi-Fi on your phone, but you can still navigate from the PDF using a variety of geospatial PDF programs, Avenza maps being one of the more common ones that folks use. So this is the general setup. You can put a title in here, or you don't have to. You can change your coordinate system here from UTM to UNSG in your data. And then everything else is more or less the same. One thing that can be useful is changing this to landscape if you want to change how you want to plot this or print this, depending on the orientation of things. And then all you got to do is click Generate PDF, and it will pull up a new tab, and now we have an actual map that's been produced. This is an actual PDF, a geospatial PDF. You can see this is no longer CalTopo. We have scales down here. We have declination and north, and then we have a QR code which allows anybody else to scan your document and pull up the same map.